Welcome to Get Your FRQ On. This question is from 2016. It's question 5, and it is not calculator active. In the question stem, we have a funnel and a function that gives the radius of the funnel for any given height h of the liquid. In part A of the question, we are asked to find the average value of the radius of the funnel. Average value is something we can find using an integral, and we're given in the question stem that at height h, the radius is 1/20th of 3 plus h squared. So the average value of the radius can be found by integrating 1/10 times the definite integral from 0 to 10 of 1/20th 3 plus h squared dh. Simplifying this integral a bit, we can factor out the 1/20th to get 1 over 200 times the integral from 0 to 10 of 3 plus h squared dh. Finding antiderivatives, we have 1/20th of 3h plus 1/3 h cubed evaluated between 10 and 0. And if we plug in 10 and 0, we get 109 over 60. So the average value of the radius is 109 over 60 inches. Inches is the unit here. In part B, we are asked to find the volume of the funnel. The volume of the funnel can be found because the funnel is essentially a solid of revolution. So if we can set up an appropriate integral to find the volume of that solid, we'll find the volume of the funnel. So the volume of the funnel would be pi times the integral from 0 to 10 of my radius function squared. So that's 1/20th of 3 plus h squared squared. Simplifying that a bit, we get pi over 400, that is after we square the 1/20th, times the integral from 0 to 10 of 9 plus 6h squared plus h to the 4th dh. That should be a fairly simple antiderivative to find at this stage in the game. So we get pi over 400 times 9h plus 2h cubed plus 1/5 h to the 5th, evaluated between 10 and 0. And when we do that, we're going to get 20,290 times pi over 400 cubic inches. In part C of the question, at the instant where the height of the liquid is 3, dr dt is negative 1/5. What is dh dt at that time? So using the formula for the radius is 1/20th of 3 plus h squared. By applying implicit differentiation, we can solve this. This is essentially a related rates problem. So dr dt is 1/20th of the derivative of 3 plus h squared with respect to t, and that just turns out to be 2h dh dt. We know two of those values. We know dr dt is negative 1/5, and we know that h at this moment is 3. So substituting that information in, negative 1/5 is 1/20th of 6 dh dt. So negative 1/5 is equal to 6/20ths dh dt. And solving that for dh dt, and then evaluating dh dt when h is equal to 3, we get negative 2/3 inches per second.